Hello ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss exponent basics. So here are two examples of exponents, 5 to the third power and x to the nth power. And we're going to discuss our vocabulary first. So what is an exponent? An exponent is a number that shows repeated multiplication. So an exponent is a number that shows repeated multiplication. So for example, if you look above, it says 5 to the third power. So let's write that down. 5 to the third power. It's a number that shows repeated multiplication. So your 3 is your exponent. It's telling you how many times you repeat the multiplication. Look at your next example, the algebraic, it says x to the n power. X to the n power. Therefore, your n is your exponent. Let's look at our next term. It says base. The base is the number that is being multiplied repeatedly. So the base is the number that is multiplied repeatedly. Back to our two examples above, we have 5 to the third power. So your base is the number that's being repeated. So therefore, 5 is your base. For the algebraic, x to the nth power, your x is the number that's being repeated. The next term is power. And power is the base and the exponent of an expression in the form a to the nth power. So the power is the base and the exponent of an expression in the form a to the nth power. And this is a caret symbol that we're going to talk about in a few seconds. Okay, so an example would be 5 to the third power or x to the nth power. Next term we're going to discuss is evaluate, and that means to perform calculations to simplify. So evaluate means to perform calculations to simplify. And lastly is the caret symbol, and that represents the raising power of an exponent. So for example, 5 to the third power. So this symbol is a caret key, and it represents the raising power of an exponent. So you may see 5 to the third power represented. The 5 is the base. Here's your caret symbol, and 3 is your exponent. Now let's discuss writing exponents in exponential notation. So let's look at our table below, and we have 3 different categories with 3 columns. Our first is the expanded form, and then we have the exponential notation, and then we're going to evaluate, also known as simplify our calculations. So now let's look at our first column, 3 times 3 times 3 times 3. And how would we write that as an exponent? Well, we would first identify our base, which would be 3, and then identify our exponent by counting how many times 3 is repeated, which is 1, 2, 3, 4. Therefore, exponential notation is 3 to the 4th power. Now we want to solve for that, evaluate, simplify. So you're going to multiply 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. And those are our answers in exponential notation and evaluating. Let's go to the next one. It says negative 4 times negative 4 times negative 4. So therefore, our base is going to be negative 4. And you want to keep it in the parentheses. And then how many times you repeat negative 4? Repeated it 3 times. So our answer is negative 4 to the third power. Now to evaluate that, you're going to multiply negative 4 times negative 4, which is a positive 16, and then times it again by negative 4, which is a negative 64. So we're going to evaluate it as a negative 64. Let's look at the third example. It says negative 2 times negative 2 times negative 2 times negative 2. So therefore, our base is going to be negative 2, in parentheses because it's negative. And then our exponent is going to be to the 4th power because it's repeated 4 times. Now let's evaluate that. Negative 2 times negative 2 is a positive 4 times a negative 2 is a negative 8 times a negative 2 is a positive 16. Don't forget to follow your integer rules of multiplication. Now let's go to the next one. We have 2/3 and times 2/3. So we have 2 2/3. Therefore, our base is going to be 2/3. And how many times is that 2/3 repeated? It's repeated 2 times. So our exponent is going to be to the 2nd power. Now to multiply fractions, you're going to say 2/3 times 2/3. And we're going to multiply across. 2 times 2 gives us 4. And 3 times 3 gives us 9. Can that be simplified? No, so it's 4/9 is your answer. So go to the last row. The expanded form is not given to us, but the exponential is negative 5 to the 2nd power. Well, here's your base you're writing, and then you're repeating it 2 times. So it's negative 5 in parentheses times negative 5. And then we want to evaluate that. A negative times a negative is a positive, and 5 times 5 gives us 25. And that's how we would expand, use the exponential notation, and evaluate anything dealing with exponents. So now let's look at a special case that students tend to get confused at times. How would we write negative 3 to the 2nd power in expanded form? Well, notice it's in parentheses. So this is your base, negative 3, and your exponent is 2. So you're going to rewrite it using the parentheses. Negative 3 times negative 3. And then we have a negative times a negative gives us a positive, and 3 times 3 is 9. Therefore, your answer is 9. So when a negative is in the parentheses, it must be kept in the parentheses. The negative must be kept in the parentheses. So the negative must be kept inside parentheses. Now let's look at our second statement. It says, how is this different from negative 3 squared in expanded form? So let's rewrite that as negative 3 squared. And if you notice, the negative is in front of the 3. There's no parentheses. So this means, when you branch it out, you are saying negative 3 times 3. As a result, a negative times a positive is a negative. Therefore, your answer is equal to negative 9. So when the negative is in front of the term 3 squared, your answer will be negative. That means that your exponent and your base are negative. Your power is negative. It's important to distinguish the two differences. So now what I would like you to do is the you try section. Please tell whether each statement is correct and show work to support your answer. I would like you to do A, B, C, and D, and we will discuss this in class. Thank you.